Welcome to Ask and Learn.
For this problem, we've been given a function in three variables, x squared plus 3y squared plus 5z squared. And what we want to do for this problem is to describe the level surfaces of this function. Now, level surfaces of a function is when we take this function and we set it equal to k, some constant. So we want to know what values of x, y, and z, we can change them as much as we want, but we want the whole function's value to remain constant. And hopefully we can change k to different constant values and we can see what's happening to our function at different points. It's a way of sometimes helping to visualize a 3D shape a little bit more clearly. So let's see what we have here. If I take this function, that's set equal to k. If I had a two-dimensional function, and I'm just going to take the x and y here. Let's say I had a two-dimensional function equal to k where I had everything's positive and I have x squared and y squared. This is the equation of an ellipse. And it's a little bit easier to see if we set it equal to 1 like we would normally do for an ellipse, because that would give me x squared over k plus y squared, 3y squared over k. And if I want to put everything in the denominator, like we often have, y squared over b squared, that would be my ellipse equation, okay? So that's the two-dimensional version. This three-dimensional version is very similar. Again, let me divide everything by k, just so you might be able to see this a little bit easier. X squared over k, that's y squared over k over 3. And I can do the same thing here, z squared over k over 5. Now, I wouldn't typically leave it with that fraction in the denominator, but it helps to see what's going on with our ellipse. So this is an ellipse. My biggest denominator is k, which is under the x. So my major axis for this ellipsoid, this three-dimensional ellipse shape, is going to be along the x-axis. And as I change k, this is going to grow, shrink, become different things. If I put k equaling to 0, then this kind of devolves into a single point right at the origin. As I get k bigger and bigger, my ellipsoid is going to expand, but these are going to be nested ellipsoids whenever I set them equal to k for these level surfaces.